Hello, welcome to today's meeting with technology to improve carbon emission reduction results. My name is Dennis Roberts, President of Energy Efficiency Done Right. For background, I am a consultant on energy efficient and glazing issues for Gersten Lerman and TGI Networks, and I've published over 30 articles on Energy Central and Energy Pulse. We're here today to talk about technology to improve carbon emission reduction results. Recently, the UN reported that climate change is harming the planet quicker than the world can adapt. It was a very dire warning because we're not doing our job. We're not adequately addressing climate change. Recently, the U.S. Department of Energy said when pursuing a decarbonization plan, the Department of Energy encourages partners to lead with energy efficiency. Energy not used is energy saved, making the transition to clean renewable energy and infrastructure easy. If energy demand reduction is not the first priority, then we are producing energy that is being wasted. Reduce energy, then right-size renewables. We must make a priority for reducing our energy consumption. This is a study that was done of strategic options for climate change mitigation. What you can see there on the far left is everything that will be cash flow positive. Everything on the right has long-term permanent cost. The best return of any option for climate change mitigation is insulation improvements. The fourth is air conditioning. The product you're going to be looking at today insulates the least insulated part of the building envelope, the glazing. It also dramatically reduces air conditioning consumption. So here's an area where we need to concentrate if we want to address climate change well. Insulation improvements. This here is pictures of the Inflector window insulator in use. This is what we're going to be talking about, a product that makes windows perform like walls. In this picture, we're seeing an office that had a lot of problems because it had a lot of westerly facing windows and it was a narrow office with a lot of glass space. This office was the hottest office in the building, the most uncomfortable, and had the most glare. In the middle of this picture, you'll see an Inflector window insulator. This is the view that you get. On the far left is no Inflector insulator. So both these windows are insulated. This window is not. And this is a tremendous glare that you get. By putting on the Inflector, you reduce the heat gain, you reduce the heat loss in winter, you reduce infiltration, and you dramatically improve the building envelope. Energy loss through glazing is the largest, most variable loss in buildings, and it has major implications on energy consumption, according to the Building Industry Data Book. Also, Architecture 2030 has said the road to energy independence, economic recovery, and reduction in greenhouse gas emission runs through the building sector. And we'll take that another step further and say it runs primarily through the building envelope. Buildings are the universal shelter. They affect almost every aspect of our life. Yet commercial buildings use 71% of the electricity in the United States, and that number is rising. Buildings are also responsible for the most carbon emissions, 38%. So let's talk about how to dramatically go after the number one source of carbon emissions. ASHRAE 90 says windows are responsible for 53% of the heat loss in a building. But when you look at windows, it's greater than that because windows are also the number one source of infiltration. So we're dramatically impacting by far the most when we address efficiently loss through glazing. Truth about windows is that windows, a single pane window, loses 20 times as much heat compared to the same amount of area of wall. 20 times. And a double glazed window still loses 10 times. 10 times more energy with a double glazed window. And that's because windows lose and gain heat in four ways. They are the thermal hole in the building. They have the most conduction, the most convection, the most radiation, and the most air leakage of any part of the building envelope. Everything that we can do to windows will greatly impact the amount of carbon emissions we have. Nothing in the world can impact carbon emissions more than addressing the energy loss to buildings and through windows. Typical window performance this summer, we have radiant heat gain, solar heat gain, damaging UV rays, and your infiltration. In the winter, we got the solar heat, but we want the solar heat. With Inflector, you can magnify that. We still don't want the UV rays. We don't want the thermal heat loss. We don't want the exfiltration. Warm air goes to cold, so in the winter, the warm air is getting out of the building, which we want to lessen. So how does the window insulator work? How does the Inflector radiant barrier make buildings work better? Inflectors dramatically reduce all of these bad elements. Reduces 72% of the radiant heat, 92% of the UVs, and about 65% of the infiltration. In the winter, we want that solar heat, but with Inflector we can magnify that because it's reversible where it's also a solar collector in cold weather. Dramatically reducing UV rays, dramatically reducing heat loss. This is a metered result using the EDTM glass test equipment comparing the different types of windows with Inflector window insulators. The blue is the amount of heat gain, of heat blockage through a single pane window. The red is a single pane plus Inflector. Double pane heat blocked, double heat gain blocked with the Inflector, and then this is your double pane low E. What you can see immediately is Inflector will outperform any of these window types, so much so that an Inflector on a single pane is much more energy efficient than a brand new low E glass window. It's even more dramatic with the UV blocked. You can see that the Inflector on a single pane, again, immediately improves that single pane, but Inflector on a single pane is much more energy efficient than the UV blocked through a low E window. Air infiltration in buildings, according to a study by the University of California, Berkeley, determined that the energy loss of infiltration in the building envelope is between 6 to 9% of the total energy budget for the nation. So of all energy used, 6 to 9% of it is through infiltration in buildings. So we can affect those other aspects of the window plus the 6 to 9% of the total energy budget, we're dramatically reducing energy consumption and carbon emissions. Here's an example of an Inflector installation. This is on the Gateway Club at Lackland Air Force Base. This is showing the front of the building. They had a big problem because they had all this glass across the front that faced west. So let's look inside the building now. This is in the building looking out those windows. Now what you're going to see here on the left picture is there's Inflector window insulators on the inside 3 windows and the outside 2 windows. These other 7 windows have no insulator. What you can see is you get a better view. You cannot see these tiles outside without the Inflector, but because of the improvement of the view, you now can see it. Here's an even more dramatic result over here. This window bank on your right has no Inflector insulators, but the ones to the right of the door do. Now look at this carpet. So you got this light streaming in. You can't even see the color of the carpet. With the Inflector incoming heat reduction, you can actually see the color of the carpet. So this light is hitting the window, heating all the air coming in, and it's being absorbed by that carpet. So we're dramatically reducing all that heat gain. The University of Nottingham did a report on materials for energy efficiency and thermal comfort. And what they found out is almost half the total energy produced in the developed world is inefficiently used to heat, cool, ventilate, and control humidity in buildings to meet the increasingly high comfort level demands by occupants. The utilization of advanced materials and passive technologies in buildings would substantially reduce the energy demand and improve the environmental impact and carbon footprint of building stocks worldwide. Inflector is the utilization of advanced materials and passive technologies to substantially reduce energy demand and reduce the carbon footprint dramatically. This is the material for energy efficiency and thermal comfort for today's world. What we have now is an Inflector zero investment energy efficiency upgrade. What we've estimated with very detailed estimations is that if you put Inflector on your windows of a commercial building and you finance it for at least 6 years, then the energy savings will be greater than the monthly payments for that energy installation. So what you've created is a zero investment energy efficient plan because the product is paying for itself while improving comfort levels and productivity, lowering maintenance costs, extending the HVAC life, reductions in carbon emissions of 30% or greater. Can you imagine if we could reduce the carbon emissions in all the building stock of the world by 30%? We would solve our target of zero emissions by 2030. And after 6 years, the savings go straight to profits. Thank you very much. That is your information. Let me know if you have some questions.